Okay, we're working on this second to the last one on the bottom page. It wanted to know the ratio of sand to concrete. So I was explaining when the video ended that it doesn't matter which one of these we use, but we might as well use the easiest one with the smallest numbers. So sand is 7, concrete is 10. So let's say you would have done this one. You would have said sand 28 to concrete. When you add those, you get 40. 28 to 40 is going to be the same thing as 7 to 10. So it doesn't matter which one you use. 28 to 40 simplifies to 7 to 10. So by using the smallest fraction given, then you don't have to do all that simplifying, but you will always get the same answer, just FYI. So sand is 7, and we said 3 plus 7 is 10, concrete's 10. So again, since they gave it in that other format, that would be the best way to write it, but these are all the same thing. So they all mean 7/10, just different ways of writing it. Ooh, here's a good one. This uses something from lesson 8. What is the percentage of concrete? Okay, Kim, read. What percentage of concrete is sand? So 7 out of the 10. So do you remember how to make that into a percent? So percent, we learned, has to be over 100. Do you guys remember that? So then you ask yourself, what do I have to multiply 10 by to make it 100? And the reason, just to remind you, because it was in the last lesson, I don't know how long ago you did that, but the reason we have to make percent out of 100 is because of the word per cent. Per means divided by or out of, if you want to use words. And cent comes from the word century, which is 100. So it's divided by 100 or out of 100. So anytime you see percentage, you know you want to do out of 100 because that's what it means. Divided by 100. So that's how I knew to immediately go to this step. Then like we did in the last lesson, we said 10 times what's 100? 10. So then we have to multiply 7 by 10 and we get 70 out of 100. So what percent is that if you get 70 out of 100 on a test? 70%. So let's write a sentence about that. 70% of concrete is sand. So 70% of concrete, and this should not be there, sorry, is sand, to answer their question. Okay, let's try some other ones. We have 9 or 10 pages full of these. You guys are going to be so sick of them by the end. We're going to skip around a little bit though, because I don't think you need to do 9 pages of proportions. Do I think you need to do 3 or 4? Yeah, to get the hang of it, to get good at it, because this doesn't go away. This is part of your math life from here on out. Okay, now we're doing punch. We did some concrete, now we're doing punch. Amy's planning to throw a party and is using her favorite punch recipe. The recipe calls for 1 liter of lemon lime soda for every 3 liters of juice. So anytime you see important stuff, you either pull out your calculator or I'm going to make this a little brighter. Whoa! You'd think after all these weeks, how many weeks have I been doing videos? I still push the wrong buttons. Okay, so find the ratio of the amount of soda to the amount of juice. So we want soda over juice. And remember what I said, order is important. Whatever order they give you, you keep it in that order. So don't write juice, soda, write soda to juice, because that would be like saying the fraction 3/4 and 4/3 are the same thing. They are not. So you have to keep it in the same order. So soda was 1, juice was 3. So, or we could write 1 to 3 or 1 to 3. Like I said on Alex, just pay attention to what form they want so you make sure and follow the directions. What is the ratio of the amount of soda to the amount of punch? Ooh, they're changing up the wording there. Okay, so this is like the cement problem, concrete, where if they give you 2 ingredients, that means there's only 2 ingredients. So if we add in 1 liter of soda and 3 liters of juice, our punch is going to be how many liters? 4 liters, right? Because we're assuming those are the only 2 ingredients. So our punch is going to be 4, because it's like 1 cup plus 3 cups is 4 cups. So 1 liter plus 3 liters is 4 liters. So they want soda to punch. So soda, again, is 1. The punch is 4. And just to save time, I'm going to just write the first 2, because those are the most common ones. But just know that's okay too. Ooh, here's that percent again. This would be a good time. Why don't you guys turn off the video and try to do these last 3 and just see if you have these 2 pages down, because we're going on to something else in the next page. So why don't you try these 3 and then come back and check them with me. Okay, what percent of punch is soda? So that would be 1 out of 4, right? But the key word again there is percent. That means divided by 100. Excuse me. So if we're going to turn this into something over 100, we have to ask ourselves, well, what do I need to multiply 4 by to make it 100? I multiply it by 25. So that means I need to multiply the 1 by 25, just like when we're finding common denominators. Whatever you do to the denominator, you must do to the numerator. So can everybody tell me what percent that is? 1/4, we already knew that, right? But let's pretend we didn't. That would be 25% of the punch is soda. And like I said, that one's pretty obvious. 1/4 of a dollar, 25 cents. So 1/4 of the punch, 25%. How many liters of juice will Amy need if she plans to make 6 liters of soda? So this is where we have to go back here. So this is juice and soda. And remember what I said, just keep it in the same order. So juice and soda. This one I know is going to be a proportion because they're giving us extra information. So I'm going to make this small again so I don't keep going off the picture. So we look at juice. And juice is 3. So we put our 3 there. Soda is 1. Says she plans to use 6 liters of soda. So I go down to the soda and it says how much juice. So there's where my X goes. So do you see what ratio we're going to use? Times 6, right? Times 6. So how much juice do we need? 18 liters of juice. And since we haven't done the other method for a few problems, let's go ahead and do that on this one too. So the second method was setting the cross products equal. So this cross product, and I always start with the left cross, or with the cross product that has an x in it, because I like my x on the left. So 1 times x is 1x, or just x. Does everybody know 1x and x are the same thing? So 1x is the same thing as x. We usually don't write the 1. The 1 it's what we call an assumed number. So we assume if there's no number in front of it, it's 1. So we get 1 times x, which is 1x, or just x, equals, and this cross product is 6 times 3, 18. Boom! Same answer we got up there. So that shows you both ways again. So if you can't see what you have to multiply, if this was, oh, I guess 1 goes into everything. So this would be a bad analogy. I'll show you on another one. Okay, how many liters of soda will Amy need if she needs 40 liters of punch? So I can see she's doing soda and punch now, right? There's no mention of juice. So soda, punch, and like I said, I always just try to keep it in the same order. So soda, punch. Set up our proportion because they're not just asking us for a ratio. When they're just asking us for a ratio, we just write the answer. But this is asking us how much, so we know we need a proportion. So then we say soda. Up here, it's 1 liter of soda. Punch, 4 liters. So that the first fraction you always get just from reading. And then it says 40 liters of punch. So under punch, we put 40, and it says how many liters of soda. That means that's going to be our x. So once again, we can look for the relationship, and I see there is one. Boom! Times 10 times 10. So x is 10. Is it liters? Yes, liters of soda. Okay, off the paper. Let me scoop this up. So 10 liters of soda. Now let's use our other method just for practice. So this cross product is 4 times x, so it would be 4x. You can either write times or just 4x, either one, they're the same thing. And this cross product is 40 times 1, which is 40. And then when I explained this earlier, anytime we're trying to get x alone, we do the opposite. And that's why I like to put that time sign in, just to remind me, oh, the opposite of multiplication is division. So divide both sides by 4. The reason we do the opposite is because we want this to be x. And isn't 4 divided by 4 1x, which is just x. And look at that. We got the same answer. Woohoo! So as you go up into higher level math, you'll probably do this more often because you'll have a calculator, so you don't care about all the calculations. But right now, without a calculator, it's kind of nice to use your proportional reasoning skills. Okay, I'm going to stop there because the video is going to be done in 30 seconds. So we'll pick up on page 3.